But before we start, I would like to introduce ourselves. Riosa as our encoder. Alessandra Castromero as our guide. And last but not least, it's me, Alexa Magnaye. In our presentation, we will show you how to apply Arduino Uno and LEDs, buzzers, and more. As a STEM student, we aim to explore the world of robotics by combining creativity, logic, and innovation. Through this project, we hope to improve our skills, teamwork, and knowledge about technology. We, the Powerpuff Girls, are excited to share our work and bring both power and creativity into the world of robotics. Arduino Uno in robotics. Arduino Uno is a small, easy-to-use microcontroller board that acts as the brain of a robot. In robotics, it helps control and connect all the parts of a robot, like sensors, motors, LEDs, and buzzer. You can program it to make the robot moves, sense objects, or reacts to its surroundings. We use Arduino Uno by writing simple codes on a computer and uploading them to the board. Once programmed, it can make things work automatically. For example, turning on lights when it gets dark or on surrounding an alarm with an sense motion. In daily life, Arduino Uno can be used in many ways, like number 1, smart alarm clock. Use Arduino to make a custom alarm that wakes up you with lights, sounds, or even a reminder of your schedule. 2. Automatic plant watering system. This helps you take care of plants by watering them when the soils get dry. 3. DIY security systems build a simple motion detector or door alarm to protect your room or belongings. In this video, we will share 3 lessons using the Arduino. Lesson 1 is all about LEDs, where we'll learn how to make them light up and blink. Lesson 2 focuses on the buzzer, where we will create sounds and alarms. And for the lesson 3 is about the 7th segment display, where we will show how numbers and digits can be displayed. These simple projects will help us understand how Arduino controls different electronic components in fun and creative ways. Now, let's start! Activity 1. Blinking an LED. Blinking an LED means turning the light on and off repeatedly. The program controls the LED by sending signals that makes it turn on for a few seconds, then off for a few seconds. This process happens again and again, creating a blinking effect. It helps us understand how to control electronic components using code. We can use blinking LEDs in many ways, such as indicators to show if a device is working or charging, traffic lights to signal warnings or changes, alarms or alerts to catch attention when something is wrong, decoration or lighting that blinks in patterns like in festivals or events, robotics or project to test and show if the program is running properly. Activity 2. Alternate blinking LEDs. In this activity, we use an Arduino Uno to make 2 LEDs blink one after another. When the first LED is on, the second one is off. After 500 milliseconds, they switch the first LED to turn off while the second LED is turned on. This process keeps repeating, creating an alternating blinking effects. Where we can use it. Traffic lights to show changes between stop and go signals. Warning or signal lights to catch attention or indicate movement. Decorative lights for patterns or light show. Robotic projects. to show the status or activity of a robot. Learning projects to practice timing and control in Arduino programming. Activity 3. Button Controlled LED. This project shows how to use a push button to control an LED with Arduino. When you press the button, the LED turns on. When you release it, the LED turns off. The circuit uses an internal Bluetooth resistor, which makes the wiring easier and helps the Arduino read the button signaling correctly. Where we can use it: light switches to manually turn on lights on or off, doorbell or buzzer to activate sounds or light when pressed, control panels to start or stop a device or machine, interactive projects for game systems that react when a button is pressed, learning electronics to understand how inputs like buttons control outputs like LEDs. Activity 4. LED brightness control using a potentiometer. This project shows how to change the brightness of an LED using a potentiometer connected to an Arduino. When you turn the potentiometer knob, it sends different voltage level to the Arduino. The Arduino uses PWM or pulse width modulation to adjust bright or dim the LEDs appear by quickly turning it on and off. Where we can use it: light dimmers to adjust room or lamp brightness, volume controls to change sounds levels in devices, motor speed control to manage fan or robot motor speed, display brightness to control screen or panel lighting. Activity 1. Buzzer beep on button press. This project uses a push button to control a buzzer. When you press the button, it sends a signal to the Arduino, which turns the buzzer on and makes it beep. When you release the button, the buzzer turns off. It is a simple way to learn how input and output work together in a circuit. In a daily life, in doorbells to make a sound when someone pressed the button, in alarms or reminders to alert when something happens, in machines or appliances to indicate when a process is done, in security system to warn when a button or switch is triggered. Activity 2. Melody player with a buzzer. This project uses a buzzer to play a simple melody by using the Arduino's tone function. The Arduino sends different frequencies to the buzzer, creating musical notes that form a true tone. Each tone has a specific duration, and by combining them, the buzzer can play a melody. Where we can use it in daily life: in alarm clocks to play a wake-up tune, in doorbells to play a short melody when pressed, in toys to produce fan sounds or music, in electronic gadgets as sound notification or alerts. Activity 3. Light Sensitive Buzzer Alarm. This project uses a light sensor or LDR and a buzzer when the light level becomes low, like when you cover the sensor or it gets dark. The Arduino detects it and turns on the buzzer. When the light returns, the buzzer stops. This shows how sensor can detect change in the environment and trigger action. Where we can use it in daily life: as a security alarm when someone blacks or enters a dark area. In automatic night alarms, the sounds when it becomes dark. For object detection when someone passes in front of a light sources. In safety system to alert when lighting fails in a room or hallways. Activity 4. Using potentiometers. A buzzer connected to a potentiometer can create a simple variable tone sound. The potentiometer adjusts the resistance in the circuit, changing the voltage and thus the frequency of the buzzer sounds. Daily use. Volume control. Adjusting the volume of electronic devices like radios or alarms. Musical instruments. Creating different tones in simple electronics instruments or toys. Testing circuits. Generating audible feedback when testing electronic circuits or components. Activity 1. Display single digit. In this activity, we use a 7-segment display to show a single-digit number. Each number is formed by finding up specific segment. The function display tree is responsible for showing the number tree on the display. It does this by turning on the correct segments that form the shape of number tree, while keeping the other segments off. In our daily life, we use a segment display to show single number like 3. The function display tree turns on the right segment to form the number. It lights up the needed part while turning off the other. We can see this in our daily life in digital clocks, calculators, and elevators. Activity 2. 7-segment display. This activity shows how a 7-segment display can count number from 0 to 9 using electronic signals. In our daily life, we can use in digital clocks, elevators, scoreboards, and electronic counters. And this is our flowchart. Start, set up the LEDs. Is the LED working? If no, then stop. If yes, LED on off, wait 1 second. LED on off, wait 1 second, and then repeat.